everyone. Welcome to the very first chapter of data structures. In this session, we'll be learning about data structures and how data structures are implemented in programs. What's the need to understand data structures? And before we get started, let's get started with a very simple question. Do you know anything about data? Or in simple terms, define data. I want you all to define data individually.
It's the
Data is collection of items. Collection of
Okay.
items.
One by one. Yes. Kusum, you can start.
Data is a collection of items or information.
Okay. Any other answers?
the same. It's the collection of information.
That's it? It's just collection of items?
Collection of information.
So if I have a list, let's say that list of fruits, like apple, orange, grapes, are those data completely? So it's collection of items, right? So is that data completely? Can we justify it to be as data?
Not really.
So data is very complex than what you have just simply explained. So data as a whole is, so data as a whole is any raw facts. So data is any information or optimized for processing and movement, facts, figures stored in a computer. Now, when you work on a computer, you are actually working with data. Now we are having this conversation. We are transferring data from one to another. We are not just limiting ourselves to selected items or selected lists. We are exchanging data in forms of media, be it the text that we are speaking about or the voice that we are exchanging. So all those are forms of data. But the problem with this is the current technology has become so advanced that the amount of data produced per second is so huge. Every second that we speak, huge amounts of data are being produced. Now the problem comes when we have so much data. How do we handle it? Imagine you have like 1000 names and you need to find those names which starts with the letter A. Now how do you do that? It's like if you start sorting them out one by one, it takes a lot of time, and at the same time it's very tiresome and waste of energy, resources, as well as it's very complex. There might be chances that you might lose a few. But when it comes to computers, we don't want that to happen. We want them to be completely accurate, completely optimistic, at the same time, very efficient in accessing it. So the terminology of big data comes into picture. Big data is nothing but a huge amount of data which has been characterized by 5 V's, which are variety. Variety means different forms of data. Now, for example, I'm showing you a PPT. Now that is a data. At the same time, I'm speaking to you. Now that is another form of data. So there is two modes of data which is happening: your visual recognition, at the same time your hearing aspect. So there are two modes of data transfer at the same time. So that is variety, volume. Now, the duration of this video is gonna go on for like 40 to 45 minutes. In that 40 to 45 minutes, how much amount of data will be generated? Whatever data I am having it, I'll be sharing with you all. And those are, the volume of those huge data is going to be very big. And the problem comes, right, when we have such huge data, how do we handle it? So that when accessing those data needs to be easy. So these are the facts that we'll be learning about in data structures. Next, the next attribute of big data will be value. How much value the data consists? Have you heard of redundancies in data? Any idea?
No.
No, sir.
Okay, so redundancy refers to like multiple data copies. For example, you might be having many friends having the same name. So when I want to sort the names, when I want to find the names, like number of names, different names in your class, I need not have the same names repeated multiple times. Those are just wastage of space, at the same time wastage of time. So how much value does your data have? How much amount of information is your data able to convey? Now that is important. Now that becomes another characteristic feature of data. Next is veracity. Now, how much information is being produced at what amount of time? Now, you cannot have the entire information just scattered around. You need a rate so that now, if I just move on very fast without any pause, neither do I give you any time to understand or process what's happening or what will you do with the data. So it is really hard to understand. So you need to have sufficient time, at the same time sufficient rate of transfer of data. So that is veracity. And when it comes to velocity, velocity is the rate at which the data is produced. Now, the way I'm speaking, every second new data has been produced. So yeah, big data will have these 5 characteristics, and these 5 V's are really important. Any doubts till now? Any questions?
One question.
Yes, please.
When you were talking about value, you told if the same data is repeated, we won't repeat it when we're recording the data, right?
Sorry, can you repeat it?
When you spoke about value, you were told
Okay.
that if there is the same data, like the same names being repeated,
Right.
we're not going to take it so many times.
Yes.
Then, so if you think there are 10 people and if the same name is repeated like thrice, but in the
Okay.
data if we take it only once, don't you think the volume is reducing because we are taking it only once?
Yes, that's what I want, right? If the volume is reduced, so less data I need to process, and that is my whole objective. My whole objective is efficient analysis of data. So if I have less amount of data, easily I can process it. See, value refers to the useful data. Now, if I have the same name, my objective is to find the different names that's there in your class. So if there is like 3 Abhisheks, now what will I do with 3 Abhishek? I know that, okay, 1 Abhishek is sufficient for me. Okay, there is a person who is called as Abhishek. So one of the name attribute is Abhishek. Now, what will I do if a second person is also Abhishek or third person is also Abhishek? That will just add on to the data and make it voluminous. Now, voluminous is a huge amount of data. Now, those huge amount of data, when I have such huge amount of data, it's really hard to process it. At the same time, it occupies a lot of space in memory, which is another drawback to me.
Yeah.
Am I clear?
Understood. Yeah.
Okay, one more point I want to add here. Nandini, you said redundancies. Okay, meaning of redundancy is which is already in excess, which is not required. That is the meaning of redundancy. For example, I use the word return back. So return itself has the meaning back. So the word back is not required there. So back should be removed. The right usage is return. So same way, when you reduce the redundancies or remove redundancies, data will be reduced. I think redundancies should not be used in anywhere. More often because of practices, we use redundancies. I think this is the right way to remove the redundancies. I think that's the point of redundancies. Yes, Abhishek, go on.
What is exactly a data structure? Now, data structure is a specific way of organizing a data. You might go through various definitions of data structures, but the simplest way of organizing, defining data structure is the schematic way how to organize the data. Now, let's understand this with an example. We all have refrigerators in our house, right? Now, what's the purpose of refrigerator? To store fruits and vegetables. Now, it's imagine a situation where you dump all your fruits, vegetables without organizing or separating them into one container, and at the same time you include all your milks, you include all your groceries. If you have all those clubbed together and the next morning you are plan on cooking and you want selected, you need to sort out. You first need to sort out, but that consumes a lot of time. You need to sort out, oh, I need these many items in these many quantities. Now, where did I keep that? You need to sort it out. So that is the reason we have different segments in a refrigerator. So understand it in such a situation where the entire refrigerator is your memory, and the different compartments are the blocks which is reserved for specific amount of data. For example, your first block will have only space only for fruits. Your second block will have space only for vegetables. And within the first block, you'll have different compartments for specific fruits, like for apple, for orange. So the next morning, you open your fridge, okay, everything is well organized. So whatever you want, you can easily access it. How much ever quantity you want, you can easily access it, and you can start cooking. that is similar to how programming actually works. Now, what is the programming actually? Any idea? Any idea how programming works? Okay, so assuming you guys have no idea how programming works, well, programming is nothing but performing any task. Okay, now for example, you are given a task of adding two numbers. Now you can't just add any two numbers, right? Now, example, you cannot add a floating, well, let's say a negative number to a positive number at the same without any computation, because the rules differ. When it comes to negative, the rules differ. When it comes to division, there's a rule that you cannot divide it by 0. So you need to structurize your data that you are not you're removing 0 from the data, so that when the division happens, there is no 0 available, so that your division goes on smooth. So that is what program means. It's execution of a set of tasks or actions. Now, programming is a combination of two facts. Now, as I said, you're organizing your data. Now, that organizing is nothing but data structure. You're actually structurizing your data, removing 0 from the division. Okay, so that whenever you perform any division operation, your division goes on smoothly without giving you any interruption. When it comes to algorithms, algorithms are the set of rules that needs to be followed. Now, there is a particular order that you need to include a plus sign in the equation. Like for example, a plus b. Now, there's that plus sign in front, in between a and b. Now, those are the set of rules how a program needs to be written. So a program is nothing but data structure, structured data, along with the set of rules, which is organized in a semantic order, semantic or a particular order, that gives you a program which solves a particular task. Now, understand this with an example. Let's consider the same example of the fridge. Now, when the data is already stored in the refrigerator, let's say all the vegetables and all those things are being properly stored in the refrigerator. The next morning, you open your refrigerator, take those particular items, which is called as accessing the data. You access those particular items and you start cooking. Here, cooking is the algorithm. You have a specific format of cooking. You first on the gas, then ignite it, then put the pan, then put masalas, then add on the vegetables or the data. Now, there's a specific pattern to it. So that is an algorithm. So your structured format with a specific rules together give you a program which will solve a problem or which will lead into which will result in an output. Am I clear with this?
Yes, sir.
Great.
Yes, sir.
Okay. Any doubts?
No, sir.
Yeah, they may come for food. We are cooking already. There is a delicious. It is already the fragrance is reaching to their places. They may reach to your place for food. Yes, Abhishek, go on it. I'm really happy with the teaching you are doing. I'm really fascinated. It's good.
Thank you, sir. Next, moving on to the characteristics of data structure. It's not just sufficient to understand the definition. We should also understand what are the features of the characteristic that is available with the data structure so that you can use it to its maximum efficiency. Now, talking about the characteristic, the first and foremost characteristic is linear and non-linear. Linear means the data is organized one after the another in a sequential order. Okay, one after the another, 1, 2, 3, 4. It's organized in a sequential order. Now that is linear. When it comes to non-linear, it is organized in random. Okay, one of the example which I can give you for linear will be an array, whereas non-linear will be a tree. So in tree, what happens is, okay, we'll be talking about all these data structures in the further coming classes. So what happens in tree is the data is not organized in a fixed format. It's not organized sequentially. So one data is here, one data is in some other corner, other data is some other corner. So that is how linear non-linear works. Then comes to static and dynamic. Static means the data is fixed. You cannot change it. For example, static memory location. When we talk about static memory location, you initialize the memories specifically to that extent that you cannot change it in the further program. So for example, if you consider this statement like int x, now int has 4 bytes of memory. When you execute the statement, 4 bytes will be given to X. Now you cannot change it when you are running the program. But when it comes to dynamic, yes, you can change it to the further extent. So what you do in dynamic is you're not initializing it, you're asking it the user, because if there are two users and user A requires 4 bytes and user B requires 10 bytes, now that will be a clash. You cannot predefine the data, predefine the amount of data required. So we go for static and dynamic. Now coming about talking about time complexity. Now data structure, as the data is organized, it will have its own time complexity to access it. Every data structure will have a set of operations that will be performed on them. For example, it's really easy to count linear data structure. For example, just imagine 1, 2, 3, 4, 5 is written in a sequence. It's really easy to analyze it. But if it is scattered, like in a crossword, the numbers are scattered. So you need to search. Now that consumes a lot of time. Now that is time complexity. Then comes the correctness. Each data must have an interface, or it should be correctly associated with its value. Now, int X should always have an integer value. It cannot have a floating point value or a decimal value. So every data should be correctly associated to its respective data type. Next, we talk about space complexity. Yes, time complexity and space complexity is is important aspect when you talk about computer programming, because an efficient program should consume less space and should execute in a less time as possible. So less time complexity and less space complexity are the two major objectives of an efficient program. So space complexity refers to the amount of space that is being stored. For example, as I said, if you consider int X, 4 bytes of memory will be stored. But when it comes to long int, when a large block of data will be stored. When you talk about structures, okay, we'll be talking about all this in the further coming classes. Just understand, respective to the data types, the space complexity also differs. Means different data types will have their own space to be occupied. Any questions till now? Okay. So this is the basic classification of data structures. So starting with data structure is basically divided into two different aspects. The first one is primitive data structure. The second aspect is non-primitive data structure. In primitive data structure, what happens is these data structures are already fixed. You cannot make any changes. Neither can you alter any aspects of the primitive data structure. These are already given to you. You cannot change it at all. So the things that come under primitive data structures are integers, float, character, boolean. In today's class, we'll be learning about all these data structures in detail. Then when we talk about non-primitive data structure, there is further two types, which is linear data structure and non-linear data structure. We have learned about linear and non-linear in our characteristic. So linear data structures will have arrays, stacks, queues, linked list, and non-linear data structures will have trees, graphs, and hash tables. So we'll be learning about each type of data structures and the operations that will be performed on this data structure in the further coming classes. Starting off with the primitive data structure. See, as I've already said what a primitive data structure is, primitive data structure are those which are already defined by the language. These data structure can be used to store only a single value, and these are the basic foundation of any data structure. These are the basic data structures. Okay, when you talk about primitive data structure, as the graph says, you have integer, you have floating point, you have character, you have pointer, and you have boolean. Starting off primitive data structures, the very first one is integer. Integer are those which have both set of positive as well as negative numbers. Those are integers. Now, integer, right? Integer is defined by the keyword int. So keywords in any programming language, there are certain words which are fixed. So when a computer or a compiler, okay, now when you write a code, how do you think a human language is being converted into a computer understandable language? Right? When you write a code, you write it in something which is in English format. You write int X, which you can actually understand. but the computer only understands the binary value, which is 0 and 1. So what is happening is this human understandable format, which we call as high level language, is then converted into a low level language or its binary form. Int x is then converted into a series of binary forms of zeros and ones. It's as simple. So integer, yes, it is represented by the keyword int, and it occupies 4 bytes of memory space from the range that you can see it in your screen. It's well, the range is not that important, but the 4 bytes of memory, now that is important. Next, talking about character. So integer stores the numerical value of integers, whereas character, that will store a string. Now, what is a string? Well, string is a sequence of characters or sequence of letters. For example, your name. Your name is a sequence of letters. Now that becomes a string. Any other character, for example, you use your ampersand sign or use your star plus. Now those individual units are called as a character. And a character data type or data structure is defined by the term char, C-H-A-R, and that will store 1 byte of memory. See these terminologies, right? For integer int, for character char, and integer stores 4 bytes of memory. Character stores 1 byte of memory. Now that is important. This is where you need to pay attention, because these will be used in your programming, and any questions they ask you will be related from this. Now talking about Boolean. Well, Boolean will store only 2 values. It can be either true, can be either false. For example, you have this condition, is 2 plus 4 equals to 6. Now what will be the answer? The answer should be true. Now in that situation, I need not, well, the computer doesn't want me, or the user doesn't want me to store that value, store the result 6. It's already there. It is just asking me, is the value correct or not? Yes or no. The question, the answer is direct. It can be either yes or it can be either no. So those values, right, have been stored under Boolean data type. And the keyword to represent Boolean is bool, B-O-O-L. Moving on to floating point. Well, that's a very interesting data structure. Floating point is a decimal point. Okay, decimal values. Any number, for example, your pi value. Pi value is 3.14. Now, those pi values will be stored in the floating point. And the keyword to be used in floating point will be float. And the data which is occupied by float is again 4 bytes. Any doubts till now?
One question.
Yes.
In the character, there are 2 different ranges given. Why
Sorry?
is that so? In character, there are 2 different ranges given. No? Why is that so?
Okay, now 0 to 255. Now that will be related to your ASCII values. Okay. So moving on to double floating point. Now, what is this double exactly? Its floating point is the same as the previous. Now, what is this double exactly? Well, imagine the pi value. Let's take the pi example. The value of pi is not fixed. 3.14, so on, right? It's never fixed. 22 by 7 doesn't give you a 3.14 value. 3.14 is just the approximation. So what happens in pi value, double floating point is, it is specifically used to store those floating points which are very huge. Double means it's going to double the value of storage. Initially, if you have seen, the floating point will have 4 bytes of memory. But when you use double floating type, right? Double floating point, it will store 8 bytes of memory. It's doubling the storage capacity. So 3.14 and so on, the entire pi value may not be accompanied in the individual floating point. So we use double, so that we give more memory space, so that sufficient, the huge data is stored in the double floating type. Then we talk about void. Now, what is void exactly? In general terminology, what do you mean by void?
Something that's empty.
Yes, perfect. Something which is empty. So those data types which are not returning any value, we use void. Let's understand that with an example here. Now you can, in front of you, below to the slide, there is this program, simple program. So what I'm doing is I'm printing the size of all the data types. Now here you can see I have written int main. So generally when you start with your basic programming, right, it will be started with void main. Now what is void main is? Void main will return you nothing. Now when you see int main, below to the code there is called as return 0. So it is returning a numeric, returning an integer value 0. So when you use void, it's not expect, it's completely empty. So you need not write this return 0. Void main means nothing, it's empty. So you are writing a function and not expecting any value in return. The program, it's a really simple program. It's written in C++. So first we'll be including hash include IOStream. Now IOStream is for input and output operators. For example, you might have seen here, there is cout. Cout is an print statement, output operator or print operator. So for that to be included in the program, we will be having this header file called IOStream. Next, we have the main function int main. Now that is where the main function or the main code which actually runs is written. So what you're doing is you're printing the size of, in the first statement, cout, size of character is size of. Now size of is a built-in function. Now what it does is size of gives you the size. For example, if you enter your name and you use the size of operator, now size of function will give you the length of your name. How many letters it is. Is it having 5 letters? Is it having 6 letters? Size of is basically used to tell you the size or the space it occupies in the memory. For example, as we said, character will occupy only 1 byte of memory. So size of character will lead you 1. Similarly, size of double. Size of double, what's going to do it? It's going to double the value. So size of double will be 8. So, and when it comes to long again will have a value of 8. So on. Float will have 4, whereas again int will have 4 again. Any doubts with the program?
No.
Okay. Now you might have a question. Now what if I require, now all these primitive data types, right? The size is fixed. Now there might be a situation where I might require more data or get some other data from external. It's not necessary. We can use modifiers. So what is a modifier? So modifier, as the name suggests, it modifies the built-in data types. So what it actually does is it adds extra features to your primitive data types. Now, for example, consider it to be long. Now, long, for example, whatever data type. Now, if you have int long, now integer is having a data type, data value of 4 bytes. Now, if you use long int, the size will be increased to 8 bytes. So the function of modifiers is to either increase or decrease the value of your data types so that your purpose is satisfied. At the same time, memory is saved. Okay. Any doubts till now?
I have a question.
Yes.
When we are writing a program, when we are declaring
Okay.
the variables that we are using, we generally also mention the size that we'll use, right? The number of characters that we use or something.
No, you actually don't. When you write, for example, consider this thing. Okay, for if you have int x, okay, int x, you're not referring any size there. You're just declaring a variable int x. Now, what the compiler will do is it will reserve 2 bytes of memory, 4 bytes of memory under the name x. You're not okay. What you are saying, I guess you might be confused with character. See, as I said, when you are taking a character as an input, now you might use just single character, for example, a. But when you need a sequence of character, for example, for your name, one character isn't sufficient enough. So what you do is you use array of characters. Now, array of characters again like a sequential memory representation. So what will happen is if you declare an array of character to be 10, so 10 bytes of memory. Each character will have 1 byte. So if you declare a character of 10, char A of 10,
Okay.
character char a space a square bracket 10. When you include that, what it will do is it will store 10 sequential bytes of memory under the same name A. Don't worry, we'll be learning about programming in the further coming classes. So I guess you'll understand that better there.
Yeah.
So brush it up soon. So we have learned about what is data. Now data is any raw facts, collection of information that needs to be processed. It is characterized by 5 V's: velocity, variety, value, veracity, volume. Then we have learned about what is a data structure. It's a structured organization of data. Then talking about types of data structure, yes, there's primitive data structure and there is non-primitive data structure. Primitive, there is integer, float, character, pointer, and boolean. And we have learned about all those data structures in detail.